I like to tap these holes and get myself a M4 size hole because it goes nicely with my other metric designs. The drill bit is just a hair bigger than the hole, so we're going to remove a little material at the start. And then the threads engage, and we have the perfect hole size to begin tapping. I like to quickly clean this up to take the burr off of the top side so we don't have interference and we don't have injuries. And then you can notice that the tabs aren't perfectly horizontal, and that doesn't matter. We're going to have clearance, enough tolerances in the mating parts that's okay. This hole was bored out just a little bit using the conical bit. You can learn that in my other hole making video. And then this one is the natural hole that comes from punching out one of the knockouts. It doesn't matter that it's not perfectly round. I'll show you why. Painted the outside but not the inside, so that if we want to, we can still ground something here on the inside. And so this round thread will pass straight through, and you can slide your lock nut on right away, but I added this bushing so that right there at the very edge you get a little interference. Sorry, this is split so that it can spread just a hair and go on. Now that's a friction fit, so that sits there, and then we put the retaining nut that came with the socket. The socket's just an online part from Amazon, and it has the Spade Terminals. I have a video also on Spade Terminals and how to crimp them. Then we have on the front side today's version of this adapter. And my focus isn't. Okay, it says version 1. This was the super quick print settings. All right, so then this, this outer diameter sits against the plate. This diameter 2 fits just inside of here, and they are equal dimensions. I measured this at 22.3, and of course it's not the same all around. So I've got this at 22.3, but there's a compression. There's a compression feature, so it can squeeze and deform, and I can rotate it and just force it in without breaking anything. And I'm going to put that split near the bottom side. I'm going to turn it just a little. You can see it. We're not in all the way. And then if we push, okay, we are in all the way, and you can see that you're nearly flush, just beyond flush. The green diameter 2 has protruded just past the thin wall. And then we have a hole here, and we have the main rectangle hole that's going to accommodate the Anderson. The orientation matters so that all my projects match, and the polarity is never reversed. Well, these ones are bonded, but you have to sometimes assemble these two using that dovetail, and there's a video on that also that I've shared, and I will try to zoom in. And my standard comes from the products that I've already found from Anderson PowerWorks that have these included. When you read the letters, the letter A, the red is on the right. So read and red on the right. And also, is it going to be like that, or is it going to be like this? In my appliance, I want it like this so that I can read. When I push these in, then, oh, see, that's just barely hanging on. That pushes out just a hair. You can feel it's smooth, and then right somewhere, oops, there's a little friction. So Well, the steel is pushing this closed, the Anderson is pushing it out, and the tolerances stack up just right so that they all hug with their friction together. And then I'm going to insert a screw here. Okay, screw is M2.5. That's the appropriate size for Anderson. And I designed for this pan head screw in my right hand, but I have to stop using stainless steel. It's a beautiful color. You can notice what stainless steel is by looking after you're used to it, but it's hard to grab onto those small screws, so stainless is not magnetic, and this one is. We'll go in there. Now the screw should have clearance on the green component and interference in the red and black. Does Anderson recommend using screws? No, but they have a pin that I'll show you that has the same diameter as this screw, so I know I'm not going to stress that plastic and break it. All I want to do is make sure that when I thread this in, I stop so I don't shear any material. This is a spring pin. You can notice maybe just a hair of a gap. When it enters, it is a little stronger than the plastic, and it spreads these just a little, but everything can still plug in with the non-sprung pair, and that spring prevents the dovetails from sliding out, and it keeps everything aligned. The diameter of this pin is very similar to the diameter of my screw, and that's how I know I can use it without breaking anything. Okay, so this fitment is wanting to fall out. On my first version, this part has too many features to verify, so I designed version 1, and I'll say I'm not going to design a feature to retain it forcefully on the first version, and I'm going to make sure A and B and C features are acceptable before I add the final features. And then in the design tree, you can also suppress or show that feature. Man, something about this focus doesn't like to cooperate. Now I have these flush at the front that it reduces the chance of mishaps, anything contacting metal flakes landing on here, making any short. And in this line, I have a replaceable fuse. The replaceable fuse and these wires came with the connector, the socket plug, and so it was already attached, as were these Spade terminals. And now I've plugged these and unplugged them a few times, and they're slightly loose. So, okay, now I'm just going to squeeze it just a little, and I don't have to worry. As long as I'm observing while I'm squeezing and looking at it and making sure I'm not crushing that circle, it's going to be fine. So I'm plastically deforming that metal just a little, and I'm not going to get this perfectly. These could wind up touching. The Spade loops could wind up touching the flat zone, but you don't. You're not going to destroy anything as long as you're looking at not crush the circles. If they're making contact, that's okay, because they'll spring back while you fit it on. Okay, so now we have it all assembled, and we have a box that holds all of our stuff, and the Spade terminals are plugged in, and we have positive down there. Gosh. Well, anyway, the terminals must be on the proper side, and if I was just building one of these, then I would probably just pull that out, lay a little bit of glue, and I would use silicone or the E600 is good for this, as shown in my adhesives video. Okay, and I would just put a little dab on that, the back of this plastic, and then clamp it on, give it an hour, and it's not going to go anywhere. That glue doesn't need to hold a lot of strength because the geometry itself doesn't give a lot of forces for this to come out. But I might change the color of this or adjust something, so I'm not going to glue it yet. Now, at the store they have tons of different options of covers or even height expansion, etc. But this one will have a flange that hangs out over my box, and I prefer to have it flush, and so I designed this cover. And this cover has several variants. That's a parametric design. So now it's just 2 screws with my favorite using metric, and that's nice. Okay, it's flush. If it sits here, it doesn't wobble. So now I can insert any car adapter. And the interesting thing is these adapters are, first of all, ubiquitous around the world. So any different country, you'll find the same matching standards, and a decent, efficient design of this car adapter is going to be cheaper than a decent wall adapter. So if you want both of these to be efficient, you'll have to spend a lot more on this one. And this is much more efficient simply because it's coming directly from a DC power source. And they also accommodate usually up to 24 volts. I think that comes from something in the trucking world. So truckers who are spending all day on the road, they want a lot of options, and so there's loads of options for them. They're usually robust, long-lasting, and cheap because there's a lot of competition. A lot of truckers out there want to change what they can power from this thing. I mean, loads of things besides USB. They have fans, and they have loads of little doodads that you might want in your life if your whole life was in your car. So that's great. Yeah, and so any of the power tool batteries, mine are rigid. Why do I use rigid? Because they have a lifetime warranty. So if I use this 1,000 times, because it's right on my desk and it goes down in capacity, I just call rigid and they send me a replacement. I ship them this one. They pay for shipping. Okay, so now I can charge stuff when I hook it up. Then I get the green light in here. That's how I know it's powered on. I could easily add a hole here, add a switch, or even use one of those ordinary household light switches that fit right inside of this box as well. Okay, so now I've got PD in my case, and because it's PD, I can select check my other video. There are PD triggers for $1, $2 each that will plug in here to your USB-C and give you 5 volts or 9 volts or 12 volts. It's selectable. So now I can run electronics on the desktop from a very hefty battery. This keeps falling out, but also I left extra cable in there so I can extend it if I want and plug it back in, or I could change this design to accommodate that better. Or of course you can change the design, because this is going to be with a whole small web page to break down the design stuff. I'll give you instructions. I'll show you the names of the files. And then this is on GrabCAD. Just search for openBox or HandyBox. HandyBox, yeah, so I posted 2 models and nobody else has modeled this yet. So that's ready. The adapters, this thing I've called the bushing, okay, and that will be online very soon. The reason it's not already is because there are like 100 variations that I have in mind. I'm not sure what should be the parent and child. If I create features like, so if you look at that USB deal, then I can suppress that. And now if I took a lot of time to make this design nicely, and you want to have something besides the Anderson there, then you can have that. And if you know SolidWorks, then you can just start suppressing features or adding features that are already designed to customize it yourself. But in the long term, we're going to have the community that has access to a lot of other tools and make this possible without using CAD. So now it's on the desktop, but later if I want it on my soldering station, then I have these 4 holes. Those 4 are going to match up to this guy. I've already published one of these with no holes, and I can publish this variant as well, and so those match up. We insert the screws from the inside. Yeah, screws from the inside, and then this has clearance, and this will go here on the DIN rail. So if you're doing things in a laboratory and you're testing electronics, if you haven't discovered DIN rail yet, you need to. And there, now I have a battery operated supply that will also do the lights or the fans or the soldering iron. This one, we're getting there. This takes a lot more power. Your battery, if you have another brand of power tools, there's loads of these adapters by now. Just in the last 2 years, they've covered almost every brand so that you can just gain access to the voltage of the battery directly. And these can crank out loads of power. Like the amp hours is one thing, that's the capacity, but then there's the power, and compared with, like you have these power banks and USB dealies, they're expecting you to be charging a phone, so call that 2 amps or something, maybe 3. They're going up if you spend a lot of money, then, but in general, these batteries and the circuits within are not intended to crank out, let's say, 300 watts. That's how much that that heat gun uses. Then we can also use this guy with a solar panel. These are generally around 18 volts, and that's perfect. So we said already we can accommodate up to 24 volts on this. It won't care if you've only got half the voltage or the full voltage. You're still going to be able to use this. Power will be limited, obviously. You don't get power for nothing. But so now I've got my Anderson connector, literally no circuitry except the diodes that protect this from reverse polarity, and then doop, plug that in. Now we have solar power as well, and we can adapt it to whatever we want. Here's an example of a lithium iron phosphate battery, also frequently used in automation projects. And so this may be the most affordable way to regulate the voltage that's safe for electronics with something standard, even if it's a no-name brand. Now, this is a $10 solution instead of designing your own circuit or integrating multiple converters to get 5 volts, 9 volts, etc. This is just the fastest way to get you the voltage that you need. In automation projects for students and researchers, they often look like this. You have electronics sipping power, and then you may have actuators with a very bulky power, like a pump or a robot arm, etc. This is the motors that are just doing physical actions. Now, in this student project, they added sensors to a robot with sensors. So maybe they are pulling 20 or 25 watts for the project. Then you have a whole different category of projects like this one, where they're moving a heavy arm and then they're driving UV light at 200 or 300 watts. So if you have this case, what we usually see students do is they'll have 2 batteries because they planned for this and then they planned for that separately. And that's okay if it's intentional, but it's double the work. Or they will boost the voltage from this battery and drain this battery extremely fast and lose a lot of efficiency because boost converters have a lot of losses. Or they'll use a buck converter and have a huge battery, and that's okay too, but then you have the work of integrating a 12-volt regulator and a 5-volt regulator, all the mechanical fixturing and all the power planning with different data sheets for each. So now for those types of projects, I recommend that you have a battery that is hefty enough, that is commonized to find replacements or different sizes, and then use this car adapter so that you can efficiently drop the power. A, it's more efficient than boosting voltage. And B, they're more cheap and more available than your professional electronics modules that will require you to do a lot of planning if it's just for a prototype. Now we can eliminate that planning and development of connectors and just have the voltage that you need with a $12, $15 part. Just to recap, we have millions of projects that sit underneath 20 watts, we'll call it 20, with sensors and computing, and those can all be accommodated usually with a 20-watt adapter for cars. Now we have one solution that's out on the internet, it's open source, and you can grab that thing, this isn't it, and download it, print the covers with the adapters, and you're ready to go. Oh, I was planning to build this page. It needs cleanup, but it's there already. And you can access the GitHub. You can view it as a web page. This is my standard method. And then as I get feedback from these videos, what do we need to understand better? We'll put knowledge. What do we need to access, like parts lists or models lists? We'll put that here too. I'll take care of that, but because it's going to be kind of infinite, how many combinations of things, I need to get enough feedback that I can put the important things there.